Okay, so today I'm gonna do your notes digitally. I'm not feeling too great, so I feel like I'm losing my voice. So I thought I'd do this in preparation for today's lesson. So today is the 15th. So let's update your table of contents. And we are doing 3.3 similar factor, scale factor, and similar shapes. And 3.4 finding lengths with similar triangles. And we're on page 19. Okay, so update your table of contents. Please pause the video so you can write this down. This is what you should have so far. Go ahead and pause the video. All right. I made a printout of your notes, so you should pick this up on your way in. So I'm going to zoom in a little bit so we could focus in on what the question's asking. So it says 3.3 scale factor and similar shapes, finding lengths and widths with similar triangles. So a couple of key ideas here is we are going to be using scale factor. Very, very important that we're talking about scale factor. And scale factor has to work with similar shapes. Okay, they go together. I can't have one without the other. Okay, we're going to be finding. This is our action verb. Okay, that's our action verb, finding. We're going to be finding lengths with similar triangles. Okay, finding lengths, and again, they have to be similar figures. Okay, it works with something other than just triangles. It works with rectangles, with quadrilaterals, any shape as long as they are similar. But we're going to first start off with triangles. Okay, so our focus question, I usually do this in red, but again, this is a printout, so this is usually our red lettering. So how can you use blank and blank to draw blank figures or find missing side lengths in similar figures? Okay, if you can figure it out, go ahead and write it in. I'm going to give it a little bit of time. Pause the video if you so you can fill it in. If you want to talk about it with your group, discuss what you think these 3 words are going to be. Once you've made a discussion, go ahead and fill it in, play the video, and see what comes up. So how can you use, and the words we're looking for here are scale factor. How can you use a scale factor to draw similar figures or find missing side lengths in similar figures? So we're going to use scale factor. That's our tool to draw things that are similar. Okay, so that's what we're going to do first. So question A, it's difficult to read here, but you do have it right in front of you. Okay, so it says for each part, draw. What I need to do is I need to draw a rectangle. This is important, similar to rectangle A. This is rectangle A. It's hard to read there because the copy came out very, very dark. So I'll put white out there just so I can read that this is going to be figure rectangle A. Okay, I'll do that over here too. Actually written in there already. It's just when the copy came out, it came out too dark. Okay, the scale factor from rectangle A to the new rectangle is 2.5. Okay, you should be able to read this in your own copy that you have in front of you. Okay, my scale factor is 2.5. Okay, and then I'm going to draw a new one. So if you know how to do that, pause the video, give it a shot, take a break, draw it out here, label the lengths. Okay, now if you don't know what to do, go ahead and continue watching the video, let it play through, and you can see what we did to solve this equation. All right, so here's rectangle A. I need to find the distance the lengths for each side. So from here to here is 1, 2, 3, 4, 5, 6, 7, 8 spaces. So from here to here is 8. And then from here to here is 4. Okay, now our goal is 2.5. So I'm going to zoom in here a little bit so we can see what it looks like a little bit clearer. Okay, our goal is 2.5. So I have a side length of 8. So I'm going to use my scale factor, which we know is 2.5, and then I should get my new width, my new value of my across left and right. And I'll do the same thing with my 4. 4 times 2.5, and I should get my new value here. And that'll be my new height. So 8 times 2 is 16, plus a half of 8 is 4. So altogether I get 20. 4 times 2 is 8. 4 times a half is 2. So 8 and 2 together make 10. So I need to make a rectangle that is 20 across this way and 10 this way. Now, since I don't have a lot of space here, and I've done this already, I know it's going to overlap. So what I'm going to do is I'm going to draw out my height first so I can get as close to here as I can. So starting here, I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's my 10 length. Okay, that's this one. And then I gotta go 20 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, there's my 20. I'll do the same thing. I'll go another 10 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And across this way, that's 20. Now, the reason why this works is because they both increase by the same amount. They have the same scale factor, therefore these two items are similar to each other. So 10 from there to there. Okay, that's my A1 value, my answer to A1. Put it off to the side so I don't take up too much space. I'm probably going to need to overlap. Okay, A1 done.
Attention.
Okay, so part 2 is interesting. The area of the new rectangle is 1/4 of the area of rectangle A. So the area, it's important to know that we're talking about area now, okay, is 1/4 of rectangle A. So this should be smaller than before. Now, if you already know how to do this, give it a try, pause the video, and work through it on your own. If you don't, follow along with me. We'll work through it. We'll make sense of the problem. Okay, so if you're playing it, either you've already worked through the problem on your own, or you weren't sure and you want to follow along the video. Pause the video whenever you need to in order to copy down whatever work is on here. Okay, so I need to find something that is 1/4 the area of this one. Well, I need to find the area of this item first. So the area of A is going to be 8 times 4, my length times width. That means my area of A is equal to 32 units. So that means inside here, if I drew all these lines out, and I drew all these lines out this way, I should have 32 of these little squares here. Now what I need to do is I need to find 1/4 of that. So for part B, this is question A1, sorry, A2 then, A2, I need to have 32, that's my original, I'm going to divide it by 4, and then I get 8 units. So I need to draw a new rectangle that's 8 units. big. Only 8 squares, and it should look something like this. Now, I could draw 8 units all different, a bunch of different ways, but it's important that it has to be similar. Okay, it has to be similar. So I'm going to draw one that is 1, 2, 3, 4 by 1, 2. So I have a 4 by 2. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 units all together inside here. And I can check to see if they are similar. And I'll do that off to the side over here to see if they're similar. So I went from 8 to 4. 8 times something gives me 4. And then I went from 4 to 2. 4 times something equals 2. If these two numbers end up being the same, then I have similar figures. Okay? So 4 on top, 8 on the bottom, 2 on top, 4 on the bottom. 8/4 and 2/4, are they the same number? Yes, they both represent a scale factor of 1/2. So yes, this is the one I'm looking for. Good. All right. Now question A3 says the perimeter of the new rectangle is 3 times the perimeter. This is important. We're talking about perimeter here. 3 times the perimeter of rectangle A. Now you have to know what perimeter is in order for this question to make sense. Perimeter is a distance around. If I built a fence around this. In 6th grade they talk about a rail. Okay, so I'm going to draw a railing. I need 8 spaces, 4 spaces, 8 spaces, 4 spaces. Okay, so if you know what to do or if you want to give it a shot, pause the video, give it a try, and then play a little bit later to see if you got it right. Okay. Okay, so if you're playing the video now, you are you've already given a shot or you aren't sure what to do. So the original perimeter, I'm running out of space here, so I'm going to write it off to the side here. I'm running out of space. A3. The original perimeter, is 8 plus 4 plus 8 plus 4. All the way around. 8 plus 4 plus 8 plus 4. Which gives me 12 plus 12, which gives me a grand total of 24 units. Now, it says 3 times. So I'm going to say my new perimeter is equal to 24 times 3, which equals 72 units. So I have to draw a rectangle that's 72 units all the way around. It's still similar to this one. Okay. Now, I know that perimeter, if you look at your notes, perimeter factor is the same as scale factor. So, if my perimeter is going to triple, that means I expect my scale factor to be 3 also. So, I don't have a lot of space. I need to go 28 by, I need to triple each length. So, in order for me to find this, I'm going to do 8 times 3. This is my 3 times. So I need to triple that length. I need to triple that length. 4 times 3. And I get 8 is 24. And that's 12. Now, if I add these all up, 24 plus 12, and I have another 24 and 12 for the other two sides. So top and bottom, left and right. If I add them all up, do we get 72? That's 8, 9, 10, 12. Carry the 1. 1, 2, 3, 4, 5, 6, 7, 8. 3, 6, 7. That's better. So I need to draw a 24 by 12. That's my dimensions. So I'm gonna start here so I have enough space. And it's a little cut off here, but I have an idea. It's right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So maybe I'll start from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's my 12 units. That's this one. Then I gotta go 24. That was 20. 1, 2, 3, 4. So one space from the end. Almost to the end. And then I'm gonna go up 12. Well, this one, I'll go one space from the end. Okay. I'll darken it up a little bit so we can see it a little more clearly. So this one is 24 from there to there, and this one is going to be 12 from there to there. It's going to be A3. Okay, so 24, 24, 12, and 12 all together make 72. All right. Work your way through question B. And I know we don't have enough space on this graph, so what I recommend that you do is just draw over the other ones in a different color. Okay, if you're not sure what to do, follow along with me. I will draw it out for you and you can see what it looks like. Okay, but if not, give it a try. You should have enough skills to go through this question, but you need to know how to work through triangles. Okay, so if you're not sure, pause it and then go through the problem to the best of your ability, and I will walk you through it in a second. All right, so it says for each part of the triangle, for each part, draw a triangle. So we need to draw, and we're going to be drawing a triangle, an important, similar to triangle B. Oops, sorry, I said draw a triangle similar to triangle B that fits the given description, and explain your reasoning. So the area of the new triangle is 16 times the area of the new triangle. Okay, area 16 times. So here we have to find the area of the original. So in order to find the area of the original, you need to do base times height. So triangle area is equal to base. Okay, so the triangle area is equal to base times height, everything divided by 2. Okay, now we need to identify our base. So from here to here, that's my base. Okay, that's your base. Okay, and from the top of this triangle to the bottom of this triangle, this is my height. So from here, I'm gonna draw a line this way to here, that's my height. So in this case, my base is 1, 2, 3, 4, 5, 6, 7. Double check, 1, 2, 3, 4, 5, 6, 7. Good. My base of 7, and I got a height of 1, 2, 3, 4. Okay, so 7 times 4, and I'm going to divide it by 2. We should have learned this last year. So just a reminder, we end up with 28. You know what? Let me scoot this over a little bit. 7 times 4 divided by 2. 28 divided by 2 equals 14. Equals 14. So I have an area of 14 units for this triangle. Okay. Now what I need to do is I need to figure out how to make this area bigger by 16 times. Okay, so I need to make an area that is 14 times 16. So I'm going to go down here, I'm going to find my new area. Okay, so B1, my area is original is 14 units squared times 16 times larger, because I want the area to be 16 times larger, we get a grand total of 224. Okay, so I need to find something that's 224 units squared. So in your notes previously, we talked about the area factor. So I can put this over here as a reminder. Area factor is equal to scale factor squared. Now, I know that my area factor is going to be 16 times. I know that this number should be 16, and that's going to be my scale factor squared. Well, what number squared will give me 16? Now, a lot of you guys might be thinking 8, but 8 times 8 is not 16. That's 8 plus 8. I want to square it. That means I'm multiplying. So the number we're looking for here is 4. So if my scale factor is 4, I need to increase my base by 4 and my height by 4. So that means I'm going to have 7 times 4. Okay, so 7 times 4, sorry, I made a mistake in my last video, so I had to make an adjustment. So 7 times 4 is 28. I wrote 21 earlier. So there it is, corrected. 28. And then I have to do my height, which was 4 times larger, because it's my scale factor, gives me 16. Okay. Now, I'm going to start drawing this out and make sure I have enough space. So I started to draw it out over here. I counted a total of 21 spaces so far from here to there, because I think I have enough space to draw my big triangle here. So this is 21, 22, 23, 24, 25. Oh, I don't have enough space to go that way. So you know what? I'm going to switch it in the other direction. I'll count vertically and I'll kind of put it sideways. So this from here to there, I know is 12. So I got 12 spaces so far there. 12, because I know that's 12. 13, 14, 15, 16, 17, 18, 19, 20. Got a marker there. 1, 2, 3, 4, 5, 6, 7, 8. Ooh. That's pretty much at the end. All right, let me make it a nice, clear, dark line so we can see it and identify where our line is. From there to there, 28 units. Okay, that's my 28 units. 28 from here to there. All right, now I need to go 16 up. So here, what you notice is it's not an isosceles triangle. It's 3 units and then 4 units. So I'm gonna get this 3, and I'm gonna do the same thing as I did before. I'm gonna multiply it by 4. It's 12. 1 all the way up to here. This is my 12 units because I got 12 measured previously. So from here, I'm gonna count up 16 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's my 16 units, which is quadruple, quadruple. That's the point I'm here. Okay, and I'm going to make this connection here. And lastly, I'll connect my last two. So this is the triangle that's 4 times larger, but the area is 16 times bigger. Call that B1. Okay, and the next one says a scale factor from triangle B to the new triangle that is 1/2. All right, so here's B. I do half of each, half of everything. So if I have a base of 7, I gotta go 3.5. I got a height of 4, I gotta go 2. So I'm gonna squeeze it in. Probably this got enough space right here. So 7. I'll just do the half. 1, 2, 3.5. I didn't go all the way across. Almost. Probably should have stopped a little sooner. Okay. And I only got to go too high. Too high because it's 4. I went 3 in. I go half, so 1.5 in, 1.5 there, and I'll go up 2. Because that was 3, make it 1.5. And I'll connect. Okay, so 3.5 by 2, right? And that's what I'm looking for. Scale factor of 1/2. Okay, this is going to be B2. Okay, and we can do our work here as well. It doesn't take up too much space. 7 times 1/2 equals 3.5, and 4 times 1/2 equals 2. That's where we got that one, and 3.5. So we got this one. Good. All right. I'm gonna jump down to question C. I'll read it through to you guys, and we'll see if you can work on it on your own. I'll put C2 down here because I forgot to copy it down, print it out for you. Okay. So it says rectangles A, B, C, D are similar. Similar. Very, very important. We have to know that they're similar. Find the length of AD. We need to find this one. We have to find this one. Okay. And explain how you found the length. So what I'm going to do is I'm going to highlight these items, and I'm going to highlight sides that are the longest side. That's the longest side, and this is the longest side. Now the reason why I'm highlighting those two is they're corresponding. Long side, long side. I know that's the left and that's the bottom, but they're both the long side of the rectangle, not just the left and left. It's long side, long side. Now I don't know what that one is, so what I'm going to do is I'm going to compare the ones that I do know. I do know the short side to the short side. Okay, so I'm going to compare short side to short side first. Okay, so the first thing I'm going to do is identify corresponding sides. Corresponding sides. Okay, once I identify my corresponding sides, I'm going to find scale factor. Use scale factor to find new or unknown side length. Alright, so these are my known values, corresponding sides, and I'm going from known to known because I'm going to do the same thing for this one, from 9 to unknown. So I need to figure out what I'm multiplying by so I can do it again. Okay, so I'll write this equation using these two numbers. So 6.75 times something gives me 3. And that number is going to be 3 divided by 6.75. So it's not the prettiest of numbers, and I don't really know what it is. It's a little bit less than a half, but I can use it over here again. So the next one, I'm going to have 9 times something equals my unknown. This is my unknown, my question mark. Now you're like, oh, I got 2 unknowns. No, you don't. You only have 1. This number is the one that we put in there. 3 divided by 6.75. And then I only have 1 unknown. So I'll type this into my calculator. You could probably do this long-handed, no problem. But for the sake of time, we've got 9 times 3. 9 times 3. Okay, that's where I got that number from. Equals 27. And then I'm going to divide it by my denominator, which is 6.75. Divided by 6.75. And I get 4. So this side length is 4. Okay. Alright, I'm going to stop it there. I'll make another video for C2 and for 3.4.